The universe is full of mysteries, and one of the most spectacular cosmic events is the life cycle of a star. Have you ever wondered how stars are born and what happens when they die? Today, we embark on an awe-inspiring journey through time and space to uncover the secrets of stellar evolution. Every star begins its journey in a vast cloud of gas and dust called a nebula. These stellar nurseries are scattered throughout the universe, waiting for the right conditions to ignite the birth of a star. But how does it all begin? Gravity plays a crucial role in this process. When a region within a nebula becomes dense enough, gravity causes the gas and dust to collapse inward, forming what is known as a protostar. The temperature rises dramatically, and nuclear fusion is about to begin. Once the core temperature reaches around 10 million degrees Celsius, hydrogen atoms fuse together, creating helium and releasing an enormous amount of energy. This process, known as nuclear fusion, marks the birth of a new star. The star now shines, balancing the force of gravity pulling inward with the pressure from fusion pushing outward. Now that the star has been born, it enters the longest phase of its life, the main sequence. This is where stars like our Sun spend billions of years, steadily fusing hydrogen into helium, producing light and heat that sustain planets and life. Not all stars are the same. Small stars like red dwarfs burn their fuel slowly and can last trillions of years. Medium-sized stars like our Sun have a lifespan of about 10 billion years. But massive stars burning hotter and faster live only for a few million years before meeting a dramatic fate. As a star exhausts its hydrogen fuel, its fate depends on its mass. What happens next is one of the most fascinating transformations in the universe. For medium-sized stars like our Sun, the core contracts while the outer layers expand, transforming the star into a red giant. Eventually, the outer layers drift away, creating a breathtaking planetary nebula, while the core shrinks into a white dwarf, an incredibly dense, Earth-sized remnant that slowly fades over billions of years. But for massive stars, the ending is much more dramatic. Once their fuel runs out, the core collapses under immense gravity, triggering a spectacular explosion known as a supernova. This explosion releases more energy in seconds than our Sun will in its entire lifetime, scattering elements across the universe. What remains after a supernova depends on the star's mass. If the core is between 1.4 and 3 times the mass of the Sun, it becomes a neutron star, an incredibly dense object where atoms are crushed into neutrons. If the core is even more massive, gravity wins entirely, forming a black hole, an object so dense that not even light can escape its grasp. But is this truly the end? Not at all. The remnants of dead stars enrich the cosmos with heavy elements, carbon, oxygen, iron, building blocks of planets, life, and even us. In a way, we are all made of stardust, connected to the very fabric of the universe. The birth and death of stars shape the universe in ways beyond imagination. From the smallest red dwarfs to the most massive supergiants, each star plays a role in the grand cosmic story. And who knows? Perhaps one day, humanity will witness the birth of new stars up close. Until then, we can only look up and wonder,